open up the data in Excel or something a little bit more powerful to kind of dive into the data. And lastly, their exhibits and seasonal events are changing over time, so they wanted a way to edit the surveys so they could keep up with the changing museum.
The solution for the problem, we created a web application for the creation and editing of surveys, as well as the visualization of data gathered from the surveys. And to deploy these surveys into the museum, we utilize Windows 8 tablets to give the users somewhere to actually take the survey. A note about those tablets, they're Windows 8 tablets, and if anyone's ever worked with Windows 8 without a professional license or 8.1, there's no way to turn off a lot of the touch gestures that are on Windows 8. So to get around that, to put the tablet into a full true kiosk mode, we found a batch script that allows us to close Explorer.exe, open up a Chrome browser with the website for the survey already plugged in, and then with kiosk mode and everything all set for Chrome itself. And then from there, the user cannot escape the system, cannot escape the Chrome browser to take the survey, and they can't mess with anything else that's on the tablet or go to any other websites. So for our architecture choices, we decided on ASP.NET after much discussion, much debates between doing a web application versus an Android application. And what it really boiled down to is we had much more familiarity with ASP.NET and MVC5 versus an Android app. In addition to that, using ASP.NET and MVC, it provided a lot of scaffolding to just get us off the ground running instantly, and along with that, a lot of ease of development for the web applications. We use the Entity Framework and Microsoft SQL Server for our backend. We use Entity Framework just because it plays very nicely with ASP.NET because it's built for that, as well as MS SQL Server because it works very well with .NET. And while we were creating the application, we kept those four quality attributes in mind. Usability, because it's a public-facing application, and it has to entice users to take the survey. Performance, because users don't want to sit at a survey for minutes on end waiting for their next question to load, waiting for data to get sent back to the back end. Security, because there's a possibility that sensitive information like emails and full names can be sent from the survey to the back end. And modifiability, so that the administrators can create new surveys when they see fit. This is a high-level architecture diagram of the application. The two major things to point out here is the login filter between the client and the web component. That separates the visitor web client, the visitor user class, versus the administrator user class, because if a visitor were to somehow get to the screen where you could log in, or where you could edit and change the surveys and view the data, they wouldn't be able to because there's a login filter for that. The second thing to point out here is the Entity Framework, which communicates between the models and to the database.
All right, and that brings us to the demo. So the first thing that I'm going to show everybody is the admin console, where people at the museum would go to modify existing surveys or create new ones. So first, let's just go ahead and log in here. Okay. So once we log in, you can see that there's a list of surveys. There's two currently in there that were preloaded. And so one use case that the museum staff would have is that they want to change one of the existing surveys just slightly. So maybe they want to delete a question or add a question. So we can go to edit the survey, or actually first let's duplicate the survey so that we can make the small changes. So the first thing that we want to do is just change the name of the survey. So let's just call that demo for now. There's also a survey description, which will be displayed when visitors actually go to take the survey. And then there's a theme associated with surveys too, which basically determines the look and feel of the survey. And right now we just want to keep that on adult. So let's just say that the museum staff want to remove a question. So I can just go ahead and delete a question. And then if they want to add a new question, they just go up here and click Add Question. It'll add it to the bottom. And so let's just say they want to know what people thought of the museum. And so the next step is choosing the type of question. There's many different types of questions, whether it be multiple choice for choosing one answer or multiple answers, or short answer where they can fill in anything. For this particular question, we'd want a slider question so that they can choose on a scale. And so for the left end of the scale, we'd want something like poor, or didn't like it. For the middle, we'd want like neutral, and then for the right end of the scale, we'd want liked it. So then, let's just say that they didn't want this question to appear last, instead they wanted it to be first. What you can actually do is click here and drag the survey up to rearrange the questions. And the question number actually changes with that. So we can go ahead and save that. And then once we created the survey, we can go ahead and actually take the survey. So this part would actually be done on the tablets in the survey, or in the museum, which would be located like around the gift shop. And visitors would just go ahead and take that. And they're first going to be brought to a welcome screen where it will sort of describe the survey for the visitors. So let's just go ahead and start this. I'm going to be doing this part all on a touch screen because that's how it's going to be in the museum. So here we can see the first question that we actually just created. And you can slide this to choose the appropriate answer. On the bottom, there's a bar actually that will display the progress through the survey, as well as text to represent that same thing. So at the top right, you can see that there's a volume icon, and that's to toggle sound on and off of the survey. Currently, there's no sound for this one, but the museum visitors can add that as they see fit. Also, right next to that is a big red X where they can go to cancel out of the survey at any time, and there will be a confirmation dialog just in case they accidentally hit it. So let's just move on to the next question here after we chose the answer. This is an example of a multiple choice choose one question. So you can only choose one answer for this, and since I'm a college student, I make no money, so I'm going to choose that. As you can see on the bottom, it updates the question number for you. So this is an example of an exhibit question where people would select their favorite exhibits. And the way that you can do that is just by clicking and dragging. And it'll drag from one box to the next. And if you notice in the question it says please choose only 4 exhibits. So if you try to choose more than that, it'll actually bring up a pop-up warning you that you can't choose more than that. And this is just a short answer question, so we can just fill that in as we need to. There we go. And here's another slider question, like we saw before. So let's just go ahead and submit that survey. So after you submit, it'll take you to a thank you screen, which will actually redirect the user after 5 seconds back to the welcome page. Also, let's say that the person taking the survey gets distracted and suddenly has to leave the survey, and they forget to cancel out of it. The survey will time out after a certain amount of time and bring you back to the welcome screen and submit any answers that were input. Alright, so let's go back to the admin console now. And so since we just took that survey, we can actually go in and view the data that was gathered from that survey. So since there was only one submission, there really isn't a lot of data to analyze here, but there's a bar graph and a pie chart to illustrate the percentages as well as the number of occurrences for each answer. And so you can cycle through the different questions, but let me just show you an example of one that has a little bit more information. So here, this is for the adult survey, and as you can see, it looks a little bit nicer once it's filled in with more data. And if the museum staff wanted to do anything else with this data, say they wanted to analyze it in further depth, they can also go and download the report and into comma-separated values format, and they can specify a date range for that as well. All right, and next, I noted before that there are themes associated with surveys, which judge the appearance of the survey. So here, if you actually click on a theme, you'll see a preview of what it'll look like. So we saw the adult, and here's an example of the child one, as well as one for mobile applications. So let's just go in and edit the child survey. And what you can see here is actually the CSS that is used to create this theme. And this can be edited. It's got syntax highlighting, but this wouldn't be done by the museum administrators. Instead, this would be more done by like their web administrator who handles their current website. You can also add JavaScript and sound to the survey. Here you can select the sounds for the previous, when they click the previous question, next question, or when they complete the survey. All right, so next there's also a detailed help menu, just in case they get a little lost on how to use the software. They can go here, just click on any topic, and it will expand it to give them more details. So I'm going to turn it over to Rob now, where he'll tell you about multimedia.
So as mentioned before, our surveys can have pictures and sounds, and we decided to have a central hub on the server sort of to hold all of this information. We wanted the pictures and sounds to be on the server and not by URL so that it doesn't rely on any outside source. And here you can see we can simply choose File to upload any pictures, which I don't have any right now, but this is where they'd end up. Let's exit out of here. And you can see that choice icons are different from exhibit icons. As you saw the survey, exhibits has a specific form of question and also their own place in the administrator console, which I will show you next. And the sounds are also in the multimedia section. So let's go over to the exhibits. The Discovery Center has exhibits that are always in flux. Maybe some are seasonal, maybe some are there temporarily. But in this page, you can create a new exhibit just like you create a new survey. And one thing to note is that each exhibit has their own rating system, which you can view via the reports page, just like you can a survey. But the most interesting part is that each exhibit comes preloaded with a single survey question. That survey is the same slider that you've already seen on a scale of 1 to 5, but the exhibits themselves come with a QR code that'll take you to the specific survey to rate that exhibit, and these can be printed off by the staff at the Discovery Center and pasted or taped onto the exhibits so that anybody can quickly access them via their smartphone. And that is all for my portion. Let's go back to the presentation. So what went well? I say from the beginning we had a great team synergy, and we owe this mostly to our bug tracking and process software, Waffle, which integrated with GitHub tracking metrics. We were able to quickly and efficiently divide tasks throughout the whole team. Everybody knew exactly what they had to accomplish and what time frame they had to accomplish it in. Our process of evolutionary delivery proved very successful because every 2 or 3 weeks we'd have a meeting with our sponsor and our client in which we'd get excellent feedback. We started out first with the development of a static survey to get the look and feel, and once they approved that, we went on to the editable survey portion, and finally we added in themes and reports. During the first semester, we spent most of our time on architecture, which ended up being a positive because during the second semester when we actually started heavy development, there may have been some additional models, but the architecture itself didn't end up changing much. And as I stated before, the evolutionary model turned out to be very successful.
The project was not without its challenges. Here are just a few. First, eliciting the initial requirements in the first semester was a challenge because the museum staff didn't quite know what they wanted, and there wasn't a lot of products that did exactly this the way they wanted it to. There's things like Google Forms is an obvious choice for surveys, but they're not targeted towards tablets. They don't have good touchscreen support, and they don't have any way to kind of make it like child-friendly, you know, and really engage children. So figuring out exactly what they wanted kind of was an initial hurdle. Deployment. I say this because we're deploying it onto a laptop that will be running in the museum, and we wanted to do an all-in-one installer for that, so they could, you know, the staff could just hit, you know, next and have it installed. But we couldn't find a great way to do that, at least not without paying a lot of money for install software. So we're currently just going to be deploying it for them on a laptop and handing that off to them, along with some documentation that could be replicated by their IT staff or perhaps Lockheed Martin if they ever need to reinstall it in the future. But that was kind of a risk we identified, you know, early on, and we never got a great solution for. And lastly, making it child-friendly, look nice in the UI design. We're definitely not front-end developers. None of us have a lot of UI experience. So making something that looks good is kind of always a challenge for us. It was a lot of kind of guess and check work, seeing what they liked. We did a lot of mock-ups in the beginning to kind of approach this challenge, which kind of helped out overall, but it was definitely a challenge throughout the project. Lastly, some future work. We saw that theme customization is done through CSS and JavaScript files. That could definitely be improved, especially since the museum staff doesn't have a lot of experience with those technologies. Having some sort of GUI or, you know, just drop downs for color selection or fonts or something was something that we wanted to add, but we didn't have enough time. For the report page, there's always kind of more graphs or you can add or filters or actually being able to export it to a Excel document. All those kind of things, you know, were just kind of extra nice to haves that we never quite got to. Improve the deployability, just like I said in the challenges, if we could come up with either an all-in-one installer to kind of do this for us, or find another hosting solution, you know, perhaps something cloud-based. But we never really had the resources to do anything like that. And lastly, survey questions that depend on previous question answers. By this I mean we could perhaps have a question where you ask a child's age, and then based on that, we give them, you know, age-appropriate questions. So the younger kids get something with more pictures and less words, and middle schoolers have something that they could, you know, with a more in-depth question with more text. That was something that was kind of brought up a little too late in the development process, so we didn't, you know, design our architecture to support that, and we had already enough on our plate, so we never really got to it. But that was a feature that the museum staff showed interest in, so that could definitely be added onto this project. And with that, we'd like to open it up to questions for you guys.
So I see you use the Microsoft Stack for everything. Did you encapsulate your SQL calls? Did you put that in your source code of your .NET files, or did you make utilization of make use of server procedures and user-defined functions? And how did that impact how you're testing for load and scalability?
Almost 100% of the SQL calls are done directly through Entity Framework. We wrote no SQL code ourselves technically. We just used an Entity and then database context as safe changes. So a lot of the load scalability was just having a test in what we use as a Telerik framework that would throw in a bunch of calls to the Entity Framework to save continuously over and over and see if the entity got in the database.
Also, we had pretty constrained hardware. We only plan to have 4 tablets at most because that's all the hardware that we have connecting to this. So like in the architecture slide, our quality attributes, we weren't really focusing on load or scale.
Will that ever scale past 4?
Currently, no, but you could make it do that, sure. But we have not tested for it.
Take advantage of responsive design so that they can display on different size screens?
Yeah, we actually partially use the Bootstrap columns, which, you know, scale according to percentage of the screen. And also we used vertical height units, so that kind of scales according to the screen as well.
All right, that's thank the team.
I think we got off easy there.
Good afternoon. We're Team Cobra. My name's Andy. This is Jim, Gabe, and Jared with me. And our project was Ouroboros, which was sponsored by our friends over at Harris. So, what exactly is our problem here? So, Harris right now is developing this new thin layer that's going to live on top of the radios right now. And what this layer does is it allows people from other companies, like those that actually buy the radio, to develop software for the radio that they just bought. Currently, though, because it's such a new process, there is no uniform process for actually getting that server up and running. So as a developer, when I have this idea of this app in my mind that I want to make, I have to go and actually install a web server and install some other means to actually store all this data and whatnot. So making that a little bit easier for the developer would also be a little bit nicer. So that's exactly what we do with our problem. Ouroboros is a single streamed process that will, following a few steps, install a functional web server onto an embedded platform. A highly customizable web server that will allow you to describe the way that you want to store data and behavior for your application. So what do I mean by data is, like, let's say that I have this radio that I want to save. I can describe things like variables, integers, strings, enumerated types, and I can group them together in a way that logically makes sense to me. So for technical people, composite pattern is an appropriate analogy. And when I say customizable behavior, what I mean by that is, let's say that I have a Raspberry Pi and it's got a like an LED on it, or maybe a motor I want to install, control. I have the ability to control that behavior, whether it's through the web server itself or through the API. This web server is also going to come with a full C++ and REST API. So even if you're not using the language C++ that the web server is written in, as long as you can use REST, you can interact with the server. So currently the system is broken up into two major sections, the generator and the generated code. The generator is a single XML file that you pass into a Ruby program, which does some Ruby magics and makes a couple of output files. Those output files are the generated code. It includes some HTML, some CSS, and some actual C++ files that go with the Mongoose server to make that actually functional and run.
Right, so this right here is pretty much a high-level view of how data flows through the system to get the server that you want. So what you start off with is an XML file, and the user defines in the XML file the data that they want the server to hold, and the kind of data it is, and the constraints on that data, the range values, and string patterns and whatnot. So we take that XML and we pass it to our Ruby program, and our Ruby program validates the XML against the schema to make sure that the XML is correct, has correct data attributes that we accept, and then we build a model from that which represents the XML in Ruby format, and then we pass that model to templates, and these templates utilize the ERB syntax, if you're familiar with Ruby on Rails. So it allows us to embed Ruby code into arbitrary text and generate text from that. In this case, we're generating C++. So we embed Ruby code into C++ files to generate more C++. And then once we have that C++, we have a compilable server. And to interact with that server, we have a web front end that utilizes JavaScript. And the JavaScript actually builds its HTML according to the JSON representation of the server when it hits it through the REST API.
So for the demo, we're going to walk you through kind of what we set up here so you can think about it as we set it up and run through. So right here we have two Pis, and on this one we have a sensor that's reading temperature and humidity data. And that has a third-party API or program that will update the values on this Pi through our REST API. On this first one we have an LCD screen and our Ouroboros server. On the Ouroboros server, we have a plugin that actually controls the LCD that listens to the temperature and humidity. As the humidity changes, once it enters different ranges, it's going to change colors according to that. So for more drier colors, it's going to be like a red or yellow color. And as it gets a little bit like more moist, it's going to be blue or purple. And is that?
Yeah, that's pretty much it. Yeah.
Cool. So as we go through that, keep the last slide in mind with the high-level design, and we'll walk you through the rest.
So, first part of the demo is configuration, because that's the first step of this process. When you the beauty of this system is that you only modify a single XML file, just one file and then a couple commands. The server layout is actually going to be described in XML, like I said. So if we can flip to that real quick. There we are. So a couple different sections here. This one at the top, that's just a way that you can describe functions, which is, like flipping a switch, running a program, something simple like that. But this is a more interesting section right here. This little group is a way that you can define a way that you want to aggregate data together. So this demo, we're going to run through a weather app to go with our humidity and temperature theme. We got two variables here, one for temperature and one for humidity. They're both integers, nothing special there. But we do have the ability to store a little bit more complex data types. So down here, we have a example of like what a radio might look like. So a radio is an integer for the current frequency we're set to, a string for the model number. In this case, the string is Harris's lovely new radio, the MCMP, and then a subgroup to that for a scan menu. So think of like the scan mode on your car radio. You got presets, and you got a Boolean saying whether or not scan mode is actually enabled or not. So, just whatever you want. You have the ability to make it as easy or simple or complicated as you like. And back to...
Back one.
Yeah, back one.
Yeah. All right.
There you go.
So the next step would be the generation step. And what we're going to do is we're going to take that XML and pass it to a Ruby generator. And we'll show you a quick, it's just going to be a quick script run, but I'll tell you what it did after it runs. So,
So for this demo, we're doing everything on the Pi. For the execution and compilation part of it, it actually takes a long time to run on the Pi, so we ran it with scripts just for theatrical effects so you can see it running. But everything is working on the Pi. We just want to speed up a little bit.
So as you can see, it says server has been successfully generated. And what that means is basically our Ruby program took that XML file, validated it, made sure it made logical sense, that the user didn't enter something that didn't make sense, such as a value of 4 with a range of 10 to 15. It checks for that, and then it passes the model to these templates and generates C++ code based off those templates. It utilizes two gems, one called Nokogiri for the XML validation, another one called RGen, which is a model-driven development framework that makes building these models and developing or generating code from these models really intuitive and easy to work with. So that was a real cool thing to learn. So now we have a C++ or a compilable C++ server. The source code's there. It just needs to be compiled, and you can now access that data that was defined in the XML.
So like Jim said, now after the server has been generated via our generator, now we're entering into the second half of the system, which is the generated code and its functionality. So here on the slide, what you see is a logical representation of the data that was found in the XML file. So you see the weather app, you see the default values that were set in the XML. So every time the server is loaded, it'll actually set those values to those variables. So in our demonstration, give me 1 second. So we are actually using AutoTools. So anyone familiar with open source projects are probably familiar to the autorecon./configure make install process. So again, that's what we're using. So that's how you create the server. The generator outputs the C++ code in place in the server tree, in the source tree, such that you're just able to run, again, autoconfigure, .configure, make, and the server is generated. So once the server is generated, then all you have to do is actually run it. One moment. Thank you. So this is actually really bad practice to run things as sudo in general, but for the Raspberry Pi, it actually does need super user permissions in order to be able to access the I2C pins that we're using for the demonstration. So don't try this at home. So also one thing of note is to see at the very bottom, maybe a little hard to read, I can fix that. It says plugins loaded. So the server does support third-party plugins that it can load and execute code. In this case, the third-party plugin that we have running on the Ouroboros server is the plugin that's in charge of updating the LCD display. So long as you conform to the plugin API that we've specified, you can load any plugins to control anything from, again, motors, LCD displays. You could even use it if you so wanted to control the Pi itself, to shut it down, bring it up, spin up another server. I'm not sure why you want to do that, but you could. And that's for the execution.
So you want to show the committee?
Yeah, start that.
Yep. So then the second part, now that it's actually running, let's see.
So we started with the first Raspberry Pi with the LCD, and now we're going to start the one with the humidity so that they can talk to each other.
Okay. So now we have the Raspberry Pi with the humidity sensors now communicating to the Ouroboros sensor, and if we go ahead.
Okay, so it's got the corresponding humidity, and if we want to make it change colors, he's going to put his hand on it, which will raise the humidity, which will change the color as it goes through the different phases, or the ranges that we predefined with our third-party API or application.
Yeah, so the way it works essentially is that the plugin architecture does allow for callbacks. So essentially, we register a callback whenever the value on the humidity variable changes. It calls a callback on the plugin, and then the plugin determines what to do. In our case, we set ranges to determine when to trigger a change in color. Cool.
So with the interaction, just to reiterate what's going on here, we are making RESTful requests and responses between the two Pis to update the value. And then with the local API, we are interacting with the LCD screen, which has a callback set up so that whenever the value changes, it gets that value and gets notified so that it can then change the screen accordingly. And we can also see this through a web UI that we built. So to go here, here's the other one we set up earlier. We just made this UI so that it can show a little bit more of how it generates it. This JavaScript code is actually completely independent of any of the generation that's going on in the beginning of the process. This just takes in the full JSON representation of the device and will generate the forms and the attributes and the different parts and fields for it. So that way it doesn't actually have to care what's on the server, it just needs to make the UI for us. And on the weather app, we can see the current temperature and humidity. And we could technically change this, but it updates every second, so it will change back in just a moment. It's not just back. But we do have the ability to change things on here and have it update accordingly. So actually, so then it changes the color right there immediately. But that's that.
So as you can see from our demo, we pretty much met all of the requirements that we were striving to achieve, with the exception of some few stretch goals that we still would like to work on for future work. But we have a highly customizable XML file that you can use to define the data types that we wanted to be able to define. Our generation code can accept all those data types and generates code successfully. The local and REST APIs are working good. The plugin architecture is really cool. It's working great. The REST API is working. The web and local callbacks, we do have a pull request for working on our web callbacks that still needs to be merged in, but that will be coming in. And the web and API function support for adding custom functions into the XML and being able to use those functions through the APIs is also working.
So challenges. So there were a couple of challenges, but these are the three that came to mind for us. One of them is technical, another one is more testing, another one is process one. So in terms of technical, one of the requirements that we were imposed for our development is that we had to use C++ 03 or C++ 98 03, which is a reasonable requirement in that most compilers available for most embedded platforms only support up to C++ 98/03. So in the sense of making this software be available for embedded platforms in general, it made sense to restrict that. But that did limit us in terms of what we could do. because C++11, which I personally have a decent amount of experience with, it offers a lot more functionality in terms of threading, in terms of functional programming. One of the compromises that we had to do is for the callbacks, we had to limit the number of parameters that you could pass because there was no concept of a functor or a bind function, or to bind parameters for a function. In C++03, which 11 does have. As you can see, we were able to make do with the limitation. And one of the problems with the testing is like, how do you test the generated code? Thankfully, a decent amount of the server code, the C++ code, is actually static, so we were able to unit test that. In terms of testing the entire pipeline, though, the way we decided to go at it is to specifically craft an XML that we could ourselves logically process and understand what the final result, for example, the final digital representation of that XML would be after being processed by the server, and then run the XML through its paces, like and make it, generate it, compile the server, and run it and get it from the server. And then it's just a matter of comparing what we expected with the expected output. With the example that we showed here, it matched our expectations. Once we merge the callback work and the function work, we will be able to test those and make sure that those are implemented properly. And then with regards to our process, one of the things that we did really well as a team is that we communicated fairly well, and we all took essentially one part of the system and became experts on that part of the system, which enabled us to work fairly quickly in the different parts. But at the same time, at the boundaries of those systems, we were sometimes blocking each other. It's like, well, I need this feature in order to progress, but wait, I need this other feature. So that's one of the biggest problems we had last semester. This semester, we focused a little bit more on our process, which is the iterative process. And so we have one large iteration, which is essentially a semester, but at the same time, this semester, what we did is every week, we essentially iterated, where we began the week by planning what we wanted to do. Tuesday was a status report, see what we're doing, if we talked about if we were blocking each other or not. Then we tried to do our best to resolve those blocks then and there, so then over the weekend we could keep on progressing, and then we just repeat that. And that really, really helped us move the development along.
So for the future work, some of these things are stretch goals that were not met, but also things that we personally like to see as this progresses as an open source project. As Gabe mentioned, the challenges, it would have been really nice to have C++11. It would have given us built-in support for different things like the RIT library that would allow us to not have to deal with different projects that weren't kept as well. And WebSockets would have been great for web UI to have real-time updating of the values instead of having to refresh the page or whenever you update a value. For persistent storage, right now when you stop the server, it loses all the memory for it. When you start up, it starts with the default values again. It would have been nice to have some feature for saving it to an SQLite file or some form of a text file with like even a dump of the JSON so that we could actually load it back in the next time. For the data types, the most complex one we implemented was enum, but personally we would have liked to see maybe some more complex ones such as images or even audio files to be stored on the server. And security wasn't one of our main requirements, but we would have still liked to have some form of authentication for it, even though this is for prototyping strictly on a local network. It would have been nice to have a little bit of auth for it.
So that's our presentation. We had a lot of fun working on it, and I hope you enjoyed listening to it. So if y'all have any questions, we can finish those now. Yeah, Brian.
So when you generate the code, does anybody have to touch the generated C++ code or modify it?
No.
No. Okay. So just for generation, that it works.
Yeah. It also places the files in the correct locations if they need to be.
So you just need to move that code onto the target device and compile it.
One of the advantages of using AutoTools also is that, for example, you couldn't technically download the source code onto like this Mac laptop or a Linux PC. You could cross-compile it using a cross-compiler. You can set a specific variable in the local environment, and you have to cross-compile the binary, then move that to the Raspberry Pi and run it there, and it would work.
And for the plugins, all you have to do is put your code in a certain folder, and we dynamically through the folder and load them all in. And it works for you.
What's unique about the plugins that I forgot to mention earlier is that the server's written in C++ 03. Technically, the humidity sensor, that's written in C++ 2014, but it doesn't matter. You can write the third-party apps in whatever you want. So as long as you can access a REST API, you can use the information on the server.
Any questions? Any other questions?
So I see you use XML for your file format. Is there any reason why you chose that over other formats?
The sponsor said that would have been a good idea. I suppose we could have gone with another mechanism if we wanted to, but XML was simple enough.
And also one of the advantages of using it is that we had schema validation, so that we could make sure that we were getting a relatively valid XML, and that would take some of the work away from our validator. So we do have we validate the XML against the schema, and then we do some extra logical processing. So this essentially automated half of the validation step for us. Anything else?
Let's thank the team.
Our sponsor was the MITRE Corporation. Doug and Lauren are here today with us, and Mark is not able to make it. MITRE Corporation is a nonprofit research contractor. Our coach was Professor Martinez. I am Stephen Brewster.
Evan O'Malley. Andrew Landman.
And Chris Farrell.
And we created the VMOF application, the Virtual Meeting Outcome Facilitator. So the problem that we're addressing with this, MITRE wanted to show off ways that technology could improve the efficiency of meetings, which we all know are frequently lacking. So the reasons this problem came up were that facilitating can be difficult for people that don't have experience with this. People can lose track of time, get sidetracked. Results are not always recorded, they can be lost. remote participants can feel disconnected from the meeting when they're not able to make it, and people can feel self-conscious about their ideas and not really speak up when they have something to say. So to address these problems, we sought to define what it means to have a successful meeting through application, come up with some commonly used activities that would be useful across the broad domain of meetings. The activities should be engaging to really help people stay focused and enjoy what they're doing. We wanted to support remote users, so if you're not able to make it to the meeting, you can still participate in the activities and produce outcomes. We wanted to support multiple rooms to simulate a real office environment where you're going to have multiple rooms having conferences and meetings at the same time. And we wanted these meetings to produce visible results so that you could keep track of the decisions that were made. And these activities ultimately really need to add value to the meeting and not detract from it. So we approached this with a web application that can run on a local network or the internet. We used real-time activities with two different views, one for the facilitator and one for the participants. The facilitator guides the activities, sets them up, and runs the show. The participants feed data into the system to produce the results for the meeting. And we support mobile users as well as desktop.
All right, so if you guys were here for the midterm presentation, you'll remember that Link chat integration was one of our requirements, but that got dropped because Microsoft was still working on an API for it. So over the winter break, we took a look at the state of the project, and we determined that ASP.NET maybe wasn't the best choice of technology to use. We really wanted to focus on the real-time aspect of it. So we switched to Node.js. So this table just shows the new tech stack that we chose and how it fits in with the rest of our architecture. So on the server, we're running an instance of Node.js on our VM, and we're using the Express web framework, which is a pretty lightweight framework. We're also using Socket.io for communication between our client and the server. And we're using the React framework on the client side, which makes it so that whenever a component changes state, it'll automatically re-render. And we're using Twitter Bootstrap to help out with the responsive design, because we need to support mobile as well as desktop users. So this is just a high-level architecture diagram. It's important to note that we've got multiple rooms at the top there because our system does support multiple meeting rooms. We've also got different controllers to handle messages for each of the 5 activities that we'll show you in the demo, and a room controller which handles users being able to join and leave the meeting rooms. And in the middle there, we're using WebSockets for the communication. It allows for bidirectional communication, so we can actually send messages directly from our server to the client. And on the client side, we've got 2 roles in the system. One of them is a facilitator, and you can have multiple attendees in the meeting. And each of these are a set of React components that we bundle together using a tool called Webpack, which is it's basically a module bundler.
Okay, so that was the architecture. So the delivered features. So if you remember during the interim presentation, we had 2 main activities running. We had icebreakers for Two Truths and a Lie, and we had a brainstorming activity called anonymous brainstorming. Since then, since the rework of our project and building it back up, we have 3 new activities that you can play around with in our application. We have Empathy Map, which is all about getting into the shoes of the customer and understanding exactly who they are and like what they're feeling. So say if we want to analyze an RIT student and set parameters of going into Facebook. We can show that in the demo. And then polling and tiebreakers is all about conflict resolution, because in a meeting, most of the time, party A and party B is conflicting over their ideas. So a quick polling between everyone in the meeting about doing A, B, or C as a decision. Say A and C is tied, you can then throw these decisions into the tiebreaker, and you can watch VMA make the decision for you. It's a fun little race that you can kind of root for your your favorite decision. And just a little recap for the Two Truths and a Lie and the anonymous brainstorming. So Two Truths and a Lie is built as an icebreaker because you go into a meeting, you're meeting new people, and you want to set off on a good note, a little light note. So you play Two Truths and a Lie, which is essentially a game. You want to fool the most people and not be the most gullible in the end. You get the high score, and you can just laugh at somebody as they believe that they're a cat. Anonymous brainstorming addresses the problem of the general in the room. So the general is someone who's running the meeting. He's like the alpha, and he has the final say in what's being decided. And say you have an idea and you're very afraid that the general's going to shoot it down. The anonymous brainstorming is a comfortable environment where everyone can submit all of their ideas anonymously, comment on them anonymously, upvote and downvote, and then set action items all anonymously. So this way it's a little more comfortable environment. And this way you can see, oh, 3 people don't like my activity, and I don't have to be mad at these 3 people because I don't know who they are. And then additionally, we have emailing results for the 3 main activities, which would be brainstorming, empathy map, and polling. So at the end of the activity, it sends out results of the meeting, so everything that we discussed in the brainstorming, all of the ideas, all of the comments, all of the action items. In empathy map, all of the items that came up, all the sticky notes will be sent out with the upvotes and downvotes and comments on them, saying like, this is the best one. You can clearly see that in email results, as well as polling on what decisions were made in the activity. The tiebreaker and the 2 truths and a lie do not have email results because they're just small, quick activities that you play without any results you really want to see. Because 2 truths and a lie, I don't really need to see who got the high score. I can just remember that because it was really funny. So that's a quick view of what we have, so let's dive into it. Wait for the facilitator to pop up. So the facilitator is meant to run on the main screen, so a large display is going to be running inside the meeting room. So everyone will be able to see this. It's not going to be running on some small computer, or you could run it on a small computer.
Full screen.
Full screen? Yeah, full screen. Okay, so we're going to set up room 1500, and the title of this is going to be presentation. And we're going to have Professor Krutz, and we have Lauren in the back going to be assisting us in this demo, as well as Steve. Okay, so you're going to meeting as well. All right, 1 second. You? Yeah. All right, so we're going to start off with a truth, truth, and lie. As I explained before, this is a fun little game. So the parameters I'm going to set for this is tell 2 truths about yourself and 1 lie about yourself. So we'll just let the participants start inputting their information. Right here, you can see the facilitator isn't meant to displaying all the information that's happening at once. It's more like digital signage and controls. So say everyone is like stuck and no one's really moving, you can kind of get up and just press proceed, or you can end the current activity and switch to a different activity. So as people start inputting their truths and a lie, on the far left side, you see the meeting participants. So as people start filing into this meeting, this list will start populating. And when they are finished, there will have a check mark next to them indicating that they are ready. If someone were to join in late, their portrait would be an X through it, signifying that they're not part of this activity and they have to wait at the current splash screen for the attendee. So we have 2 people ready. Steve, if you want to demonstrate a late activity. Oh, Lauren, we're waiting on Lauren. No, we're good. So the current liar is Andrew. So on the attendee side, you'll see that they can see all the different inputs that Andrew has said, and they have to guess which one is his lie. And let's see. Is that cross rules?
No, it is. It can be anybody.
All right, so Andrew lie was?
Then I click it.
Yep, there we go. I'd be shocked. All right, now we're going to go for Krutz. Krutz cannot input anything. You will see a little sign that says, be cool, people are figuring out your lie. It's a fun little message saying, please wait, as everyone's trying to figure out what your lie is. Okay. I find that hard to believe. All right, and now we have Lauren. Additionally, when they do take a guess, there's a spinning wheel saying that we were waiting for the big reveal. This is more digital signage to let everyone know that we were still waiting for everyone to finish. And Winter is my favorite, was her lie. So now we go to the splash screen. So we can see that Krutz ruled. He fooled the most people, but he was also the most gullible. He'll believe anything you tell him. So take that. Take a note of that. All right. So now we'll move on to the setup of the brainstorming activity. This is a more in-depth activity, so we won't dive through the entire activity itself is we can show the setup. Or we can
I
highlight it
can't
all.
see anything.
Oops, sorry. All right, so if you want to go to the advanced options on the right. So additionally, you can just click brainstorming to just arbitrarily brainstorm about anything you say, or you can set parameters, such as what makes a good presentation. And we can set some ground rules. We can set the limitations of how many inputs that the users can input. We can set time limits on the 3 different phases. Additionally, we can upload an image. We don't have to upload an image right now. And we just hit the start button.
Oh, I cancel that.
Yep. There you go. Okay. And this is a little warning message that will pop up because we want to make sure that when you start an activity, everyone is ready to join. To say someone's logging in, they can quickly throw up their hands like, hey, wait up, and then you can cancel out and wait for everyone to come in and then start the activity. So this is the facilitation screen for the brainstorming activity, which will just show the topic, what makes a good presentation. So then users can then start inputting into the field, and then when they're ready, they can click ready up. So we see that user 1 is ready, user 2. So notice how all of the users don't have their names anymore. This is for the anonymous brainstorming because you don't want your name associated with your ideas, hence being anonymous. Okay. So as the phases are moving through, the facilitator is just digital signage. It's just telling you exactly what's happening. So we're at the brainstorming session, now we're moving on to the commentary phase. So each of the attendees will then be typing in their commentary for each of the different ideas. They can go through them all, they can upvote them, they can downvote them, type in an idea, press enter to signify all their comments. So we see that everyone is still going through talking about each of the ideas. We see Krutz is having a fun time over here with this application. We can wrap this activity up because we do want to show the rest of this. So, all right, we're going to end the activity here. No! Okay. So if you put in an email, well, at the end of this activity, you will get all the main results that are associated with this.
We'll show you an example of that email. So.
Yep. Next, we'll show empathy map, which is really cool. And so MITRE actually uses this. So as I said before, it's all about understanding the customer. So say the customer is the RIT student. So let's understand what the RIT student is. So each different section will see here, this is an empathy map. So the way this is traditionally done is either you display it on a whiteboard or you print out a picture of it, and everyone gets a post-it note and start putting it on the board. You can see that Andrew just posted a post-it note on the whiteboard. So this is what the empathy map is. So all about like, what does the RIT student see? What does the RIT student think and feel? Apparently, Krutz thinks we're crazy. So what do they hear? What do they say? What do they do? So it's all about understanding who your customer is, and you can build your product around them to address their needs. Oh, this is gonna go south fast. All right. So again, when everyone's done inputting all of their ideas, they can hit ready up and they'll be moving on to the commentary phase. So then you can go through and specifically address, so, oh, I like this comment, and then upvote it. And at the end, it's all about signifying what was the best comment. So those are then ranked. So the highest rated comment will be at the top of each section. So we're still on the input phase. So at the top, there's a bar that tells you exactly what phase you're on. So currently we're still on the first phase for empathy map. And then next will be the commentary and then discussion phase. This bar is at the top of all the activities to tell exactly the users in the room what exactly is happening. Okay, so we see that Lauren is ready. And Krutz is ready. So next, we moved on to the commentary phase. So the facilitator doesn't need to show you what the comments are because it's just showing what the post-its are. On the attendee side, like I said before, you can input all of your different thoughts about all the comments and upload and download them. So then we'll let a few people just ready up. Just type in one comment, please, and then upload one thing so we can end this activity. So there's a lot more to show you. So actually, we're going to wrap this up a little bit quicker than we expected. So we're going to end the activity right now. So we can do a quick overview of what polling is. So polling is, you put in a question, you put in all your responses, and you can add up to a few more than just 2. And then we're going to show you quickly what a tiebreaker would look like, say if we can't decide. say we want to decide what grade we should get on this presentation. So we can add A, B, and then we can add all the way down. We can't add more than 5. A, B, C, D, and F, and we can let VMOF decide what grade this should get. So imagine like you're in a meeting and you are trying to decide between options A and B. This is a fun little way for VMOF to decide for you of what exactly should be happening. Should we go for option A or option B? Oh, come on.
No.
Oh,
Right.
yeah!
That was not rigged.
That's not rigged at all. All right, so this is the bulk of our application. So I'll turn it over to Chris to tell you to wrap up the presentation.
Define the presentation first. Give us a second. Oh, there it is. Excuse us for just 1 second. Pull that up a bit.
There we go. So, the current status of the project is we have the 5 completed activities, most of which you just saw. We have the multiple rooms to allow users to be in different meetings. So you can have a meeting in this room, you can have a meeting over in one of the team rooms, and they're all separate meetings with their own separate set of results. We have the email results. So those of you that participated in the activity, you should have an email out now which will have the results of the activities you participated in. An individual email for each activity you participated in. We also have mobile and desktop support. Since you might have users that aren't in the room with you, we want to make the signage between the two of them as similar as possible. So the mobile view looks the same as the desktop view, just slightly smaller. And we're preparing for the handoff tomorrow to our sponsors. So some of the challenges we came across. We have the requirements and the ideation in the beginning. So when we were gathering the requirements in the beginning, the team expected that we would have the requirements kind of given to us, and MITRE kind of came in with only a few ideas of what they wanted. They wanted us to kind of pick our brains and come up with something good. So it was a very big challenge we had in the beginning. One of the biggest challenges we faced was testing. The way we had all of our frameworks together didn't really lend itself well to any of the testing frameworks we found. We tried Nightmare, JS, Phantom JS, Mocha, Jasmine, Telerik, Selenium, and none of them really worked well for us. So a lot of our testing was done manually, and obviously that led to a few other problems. The tech stack change. So because we had to change tech stacks in the middle of our project, we had to play a little bit of catch up. And so we had to try to create as engaging and intuitive of a user interface as possible. And we created activities that we had to create activities that added value to the meeting. Right. Okay. So what went well? We had all the required features completed. The tech stack change went as well as we possibly could have imagined, and we finished with a good working product that the team is proud of. But what didn't go so well? So we struggled with our process. We all kind of documented things in our own different way, and it led to a lot of problems when we were trying to combine all of our efforts and figure out where our efforts were spent. All of our testing was done internally, especially like our usability testing, which kind of led to a few problems along the way. And we had different coding styles between the activities. So we all kind of coded up our activities in our own separate way, and it led to a few problems with integration. Our future plans, we wanted to have data persistence. We wanted to have data that would persist throughout the application. We wanted to be able to process the data, especially for the empathy map and brainstorming. We wanted to add in more activities so we could make the application more engaging and more as user-friendly as possible. We wanted to implement chat integration, as the Link API sort of just came out, so we were looking to go back to that, but we didn't have the time to do so. We wanted to add in sensors, be it a webcam, a microphone, or something that would just audio hotspot in the room. And we also wanted to do tutorial videos for each activity. So are there any questions?
How well does this play with other meeting tools like WebEx or PowerPoint? I mean, you can see that sometimes even just managing between 2 or 3 applications can be kind of difficult. So how does it integrate with those other things?
It's more of a supplement to your meetings. It doesn't necessarily integrate with any other existing. We wanted to integrate with Link originally, as we said. That would have helped in some ways as far as setting up, meeting times and, other follow-ups. But that wasn't a requirement of the project. It was mainly as a way to just sort of an ad hoc say, we need to do some brainstorming, so let's do this activity.
So you had talked about including people who weren't present in the meeting and making them feel as a part of the meeting. How did you address that specifically?
That's just through the signage and how they're able to see what's going on as far as status updates. You can see what the facilitator is doing, what type of activity they're setting up, if there's an activity in progress. And as we said in our future work, we'd like to have chat integration so you could talk directly. But we assume that in any normal remote meeting, they would be already, vocally, speaking to the people there. So.
You were on the facilitator. It looked like the facilitator couldn't actually see any of the discussions going on. Is that on purpose?
Yeah, the stuff on the main screen is just to supplement what's going on the individual phones and laptops that people are using.
It's all about digital signage. The facilitator is not there to display all the information, save for just 1 or 2 things. It's not going to show everything. It's just going to show you what's happening next, what's happening now, and what's going to happen. Anything else? Oh, maybe.
Is there is another feature we'll perhaps connect to like an agenda for each meeting so you can have like a template almost of different activities? Because I can see sometimes like certain people just not wanting to do one activity or another.
Yeah, that was an early requirement that ended up getting dropped. It was tended to be out of scope, but that was one thing we wanted to do, was be able to put these activities into a string where you could just go through them one at a time. But we didn't have enough activities to really fill out an agenda to begin with, so it got dropped.
We are the Standard Deviants. I'm Julian. This is Robert, Morgan, Salvador, and John. And our project is Golly, the Graph Object Layout and Language Editor, and that we worked for 2 Sigma.
So graphs are hard. 2 Sigma does a lot of work with graphs. They do data transformations, network infrastructure, so like looking at how servers are connected, how pieces of infrastructure are interconnected, and architecture diagrams. So some of these graphs are insanely huge. The graph we have there, which is hard to see, is 540 vertices and around 24,000 edges between them. So laying that out is difficult and being able to see that. So our challenges were a plain text markup language so that a human can sort of read it, custom types and styling, and then an automatic layout that can deal with that.
So what exactly is Golly? As John said, it has various parts. The first part is a human readable language. So we have 3 separate languages. A content language, which is basically the meat and potatoes of the graph. It's what drives the graph. It's what states basically what the graph is, what the contents of the graph, which nodes are, or which vertices and what are the edges. We have the style language, which defines the style of the graph. For example, if you want to change the color of a specific vertex to be red, you can do that as well. And we have the layout language, which is kind of an important part of our application, which is when you edit the layout of the graph, this persists that layout and saves the new position of the vertices. So as I said before, it combines the automatic layout with a manual layout, and this manual layout is persisted. Here you can see, even though this is a smaller graph, it is kind of easier to visualize. We change a little stuff around, and it's kind of easier on the eyes than what an automatic layout would have done with this graph.
So there are some existing tools for graph visualization and editing, but 2 Sigma wanted their own tool for this because some of the existing tools fall a little bit short in important ways. For instance, CMap tools is a piece of software for editing graph layouts, and it does automatic layout, but it's pretty slow. And also, it does not have containers. So 2 Sigma's definition of a graph that they wanted for this project is not quite the same one that you learn in discrete math. So you're used to vertices and edges. But in addition to that, 2 Sigma wanted ports on their vertices, so these are the things that the edges actually connect to. And then also containers, which CMap does not have. And it also does not have ports. And the files that it creates are not especially human readable. They're not made for that. They're just made for graphical editing. And then there's also GraphViz, which is not, I believe it's not an interactive tool, right? Yeah, it's, so you can't, if multiple people want to edit the same graph, or if you want a live updating graph, you can't really have that with GraphViz. Also, the syntax is, again, not quite what they'd like, not as human readable as they would like. And you kind of have to monkey around with it to get it to work on Windows, so that's not fun.
Okay, let's dive into a demo.
Okay, so basically we have our little application here, and you can see we have a little editor there. It's a placeholder while we make the uploadable files. So if you hit apply, it will display the graph, and as you can see, the graph isn't really pretty. It's not what you want to see when you look at a graph. So what we can do with this is we can edit the graph around a bit, move the edges around to make it more easy on the eyes, more visually appealing. And okay, well, as you can see here, though, there's a little pin icon. If you hover over the port, real quick, there's a little pin icon. That basically is what saves the layout of that pin. So if we move the pin around on the vertex, the pin will identify that port as being moved, and thus would save the new layout for that port. The same thing happens with edges, vertices as well. You could also reroute edges if you want to make them go around vertices. And yeah. Also, we talked about containers a little bit. There's a It's not okay. Okay. Sorry about this. I thought we had this.
So what you would be able to do while they're fixing it, I don't know what's going on. You should be able to. You can see that that's a container. It has hard edges. It may contain more graph data, and you can click and go into it, and then click and go back out. Do you want to move on?
So we apply, you find that vertex here.
So as you're dragging it, the reason the other vertices are moving around is because it's relaying out. You haven't said yet where you want those to be, so the layout algorithm is running again and doing an automatic layout to where it thinks the best place for the other
As you
vertices
can see, we went into the container Shrek, and it has the movie Shrek 2 in it as well. This graph, by the way, is just supposed to be a 6 degrees of separation, or 6 degrees of Kevin Bacon graph. Just a little bit of fun there. So if you want to go into the container, you just double click the vertex, which is the container vertex, and it is differentiated by having rough edges rather than these smooth edges here. So double click on it, and you're in the container, and you can see what vertices are inside it. And if you want to go back, you simply hover over here and click back to the root. Let's go back to the presentation.
So I will talk briefly about a simplified version of our architecture. So Salvador talked about the three languages that we have: our content language, style language, and layout language. These go through a pre-processing, lexing, and parsing steps. And we use a technology called JSON, which maybe some of you have heard of Bison, which is in C. It's you write out what your language grammar is, you define your language grammar, and it actually generates code for the parser. But this is in JavaScript, that's why it's called JSON. So we parse these three languages, that creates an abstract syntax tree, and from that we can create our internal data model objects. And each of those map to components in React to visualize them. And then in the case of the layout language, when you drag things around, it changes those data models and then goes backwards to generate a string of layout language so that we can save that.
So just to talk a little bit about the project status, we've made a lot of progress on a number of areas in the project. The visualization is in good shape as far as the UI itself. We also have, as far as functionality for the markup language, that is complete per the sort of initial agreed upon requirements. We have a functional automatic graph layout, and we also have the ability to manually specify the layout of vertices on the graph. We also have an API in place for actually storing graph content. There are definitely some things that could use a little bit more work though. We don't actually have the graph, the actual storage API integrated with the rest of the application yet, which is why we have that little sort of small editor in place for actually adding the graph content. We also have a few issues with the manual layout where there are just a few bugs regarding persistence, so that's why for the layout we can't persist it in the demo. The style language, due to having to prioritize different aspects of the project, we didn't quite get around to that. And GCL templating was a feature that the sponsor requested that we made some progress on, but it's not in a demoable state. So we're not showing that off. Tree arrows for the visualization. As you noticed before, there are some vertices on there that have a lot of different edges coming out. One of the features that the sponsor requested was the ability to specify that you can have sort of a tree arrow come out of that. We didn't get around to doing that. Some other areas that need improvement. The parser is a little bit slow in spots, but fortunately it's kind of like low-hanging fruit. Just due to having to prioritize different aspects of the project, we didn't get around to it.
but fortunately it's, again, low-hanging fruit. There are also some ways that we could improve the performance on the visualization side. Using different parts of React, just using some of the different functionality there, would improve performance for large graphs.
So we did encounter some technical challenges in doing this. So we started out with to render the SVG on the page for the actual visualization. We started out using a framework called D3, which you may remember from our interim presentation, and we found that D3 kind of lends itself to writing very messy code because it's sort of it's hard to get the state out of it. But React is nice in that it's very declarative, so the state is, it only flows in one direction, it flows into the view components and only in, so that's nice. And so we settled on using React, but that sort of came with its own problems because React is a little bit finicky about events. And so there's a particular architectural pattern you're supposed to use with React, and we struggled with that a bit. Another thing, in case we didn't mention before, graph layout is hard. You remember that huge web of edges. Well, if you're thinking of time complexity, that number of edges is n. So yeah, this is a hard problem. Also, in just working with JavaScript, it's missing a few basic features, and this was a little disorienting to a few of us because we're all pretty new to JavaScript. So for instance, it's missing some collections that we would have expected it to have, and arrays don't perform the way we would expect. Object-oriented programming was not quite what we expected it to be, and like I said about React, it's a little finicky about events, and we kind of had to write our own utilities for that.
So things that did go well for us, though, the fact that we were targeting just Google Chrome was very helpful to us. It let us really focus in on a very well-supported and very supportive of us platform. Not having to jank around with IE was a great help to us. Our team dynamic, the whole project through both semesters has been very good. You know, when one person gets stuck somewhere, someone else has been able to come in with a fresh pair of eyes and help them and get around whatever that issue was. Our sponsor has at least appeared to be very happy with what we've done. But some of the challenges we had just in general, we used Jira for a lot of our stuff, and the tool didn't really fit our process very well. It took a lot of, Jira Agile is sort of a patch over Jira to make it kind of work for Agile, but didn't work great. Our instance of it was not very stable. We had a lot of problems just keeping it running and not having it die on us. And its usability wasn't great, and we ended up spending some weeks more time on Jira than we did actually working on the project. We also had problems just juggling coursework, senior year. And also our integration/demo cadence. We were trying to do weekly releases and a demo every week, and we just never got up to that speed. We'd spend too much time trying to integrate. We didn't have as good integration planning as we probably could have.
Great. So one thing that is good about our project is that it's an open source project. And in fact, if you want to go ahead and try this out right now, there's a link for it right there. Take a look at it when you get a chance. It's released under an Apache license. There's going to be documentation put in place on the GitHub wiki soon. And then one of the other good points about this project is that one of the, some of the really important things from day one has been making sure that this code is maintainable, that the next group of people that work with it don't have to fight the code base. So from pretty much day one, we've had high unit test coverage. Right now we're hovering around 80% unit test coverage. Our sponsor requested a minimum of 40%. So we've kind of gone above and beyond there. We've had a consistent coding style with it. We've made sure that we've had tooling in place to sort of enforce that. Additionally, extensibility has kind of been a primary concern from day one. So everything in there should be extensible. We made sure that our code was modular.
This little guy, by the way, is we have a linting environment where we all lint our code, and we have a style guide that we follow, and that's been very helpful in making sure that our code is very consistent and we can hand that off. But for people who don't follow the linting guidelines, this little robot comes into our GitHub and comments on our pull requests to make sure they're all clean. So some of our feature goals this week and last week, we've been cleaning up some critical things. Like Morgan said, we have a storage backend and we have a front end. We just need to integrate them. Performance on the layout has been slow, but it's actually increased about tenfold this last week, so that's definitely improving. And persisting the manual layout, again, that's there. It's a little buggy, and we just need to clean that up. But in the future, we want to add language templating, which is like object-oriented features for our content language. We need to implement the style language, inline containers, so instead of clicking in and going to a whole different screen, you should be able to just expand and contract containers. And again, tree arrows are some of our feature goals.
Any questions?
So I talked about algorithm complexity. Well, there is one is memory complexity. That's an issue for you guys. If someone goes through software requires like an Excel abilities to like take up all memory.
That hasn't been a bottleneck so far that I've noticed.
Yeah, it hasn't yet. Theoretically, eventually, yes, it would become an issue. But you're going to be looking at runtime issues long before you start getting into running out of memory issues, where you're going to be seeing probably runtimes in the several minute range. Right now, for that 540 vertice graph with 24,000 edges, we're at about 10-second runtime on laying it out. So.
And that was a test case. That was like a low test case.
When it lays out the graph, is it making any attempt to organize it, or is it just laying it out randomly?
Well, it's not doing it randomly.
It's using a spring algorithm where essentially it's trying to cluster things that are heavily related together, and things that are unrelated should be pushed apart, in theory.
So if I ran it twice, would I get the same?
Yes.
Yes. We actually, we sat down and an initial version of the layout algorithm was not deterministic, so if you ran it twice, you might get different output. But yeah, we paid special attention to that, and a subsequent iteration of that was deterministic.
Just out of curiosity, how did you come up with that 80% metric of the tool you ran?
Sure. So we use a tool called Istanbul during our unit test runs to actually, and it's kind of cool what it does. And I guess just a little bit more background, we're using Gulp as kind of like our test, sort of our task framework for different aspects of the project. But what Istanbul does is it'll actually like instrument the JavaScript code right before the tests are run. So it can actually tell you not just like function level, you know, these lines are run, but it can also give you insight into like module level, okay, these modules were actually tested in the first place, how much of them were tested, things like that. So that's a really cool tool for just JavaScript testing in general. But we're using that with Mocha as our actual like test framework, and a couple of other different like assertion libraries and other things.
You mentioned that Jira didn't work for you very well. I'm just wondering, how did you go about doing the setup? Did you use an academic license? Was it running on your virtual machine? And
Sure.
what specifically of the entire thing were you trying to use?
Sure. So we were using the senior project VM for actually hosting our Jira instance. In particular, this was like a personal license that I purchased a couple of years ago that was just sort of sitting around, so I figured I'd use it for the project. We were hosting it on our own. Some of these problems probably could have been solved by using essentially like Atlassian's hosted service, but that costs money. As for how that relates to our sort of process, just as some background, we're using Scrum as our actual process model. And in this case, with Jira, again with Agile, they do kind of have this model of sprints and other things. But as far as just like usability, it throws a lot of fields at you, and when you're actually trying to like do things with it, like say you're just trying to add like a story, it takes a while because there's a lot of different fields you have to fill out. You kind of have to like navigate it. There's a lot of overhead to it.
Yeah,
it's kind of imposing.
I mentioned that I think once you get to using Jira and you've gotten your process down, you've gotten it set up, it's actually a pretty good tool. But before you figure out how to use it, you wind up doing dumb things, and that's how we lost a lot of our metrics, for example, because we didn't know how to transition things between sprints correctly and other things like that. So we did wind up losing data.
Any other questions?
Yep.
Everybody ready?
All right. Good evening. Good afternoon. We are the Weather Hub team, and we did the weather.rit.edu website for our senior projects. This is next. So, project at a high level is to provide the RIT community with the near real-time weather conditions of our campus, and then collect that weather data and store it for scientific purposes in the future. We have two sponsors, RIT staff. We have Jim Stefano, he's an assistant administrator for the engineering college, and we have Bill, he's working at CIAS. So in terms of like project context, there's no previous history for any kind of system like this. So everything was pretty much new. The domain for this project is obviously the weather, and that was kind of a challenge in the beginning because we didn't know what like software and weather, how they work together. We didn't know about weather data formats, and that kind of hurt our architecture a bit early. There's also the deal with weather sensors, and to this day we have one, and it's still kind of a mystery to us. It is temperamental to say the least, and sometimes it just kind of goes down and hurts our system in strange ways. And there's the networking issues there too. Also, there's just the general weather systems and weather services around the internet, like National Weather Service. They provide many APIs and feeds and useful data like radar and forecasts and stuff like that. So our main goals for the project was, number one, users will have access to the campus data. Number two, users will be able to look at it on the internet. Number three, be able to collect the data and retrieve it for pretty much anyone. And number four, this project is the foundation for future expansions, future sensors, future feeds, how those indications, and user classes for this is basically an RIT community member, just a student, faculty, staff. You wake up, you look at your forecast, look and see how bad the weather is on campus, that kind of thing. Something else was a domain expert, someone kind of external to RIT, but they were curious about the weather here. Another one is maybe an academic on campus who actually wants to take the data and use it for scientific purposes. So with that being said, I'm going to hand it off to Chris and talk about system architecture.
So system technology, we use Node.js and Express as our web framework. We use LinkedIn Dust as our templating engine for the HTML. We use Redis for our caching mechanism and MongoDB for our database. Because since our data is time series, it made sense to use a NoSQL database instead of an SQL database because an SQL database would end up just being one huge table. So it made sense to use something that's a little bit more flexible. And we use high charts for graphing all our information from the archive data. So this is a real high level of our system architecture. Essentially, we have a presentation layer that's our templates. We have our business layer, which is all our Node.js functionality. In our business layer, we have a set of domain logic that talks to our NWS, which is the National Weather Service. That's where we get all our radar data and our forecast data. We also, in that layer, we also talk to our external sensors that Connor mentioned. And below that is our data proxy when we talk to our MongoDB and Redis. So a big issue we had at the start was that our weather sensor was very sporadic. Sometimes it would go down, or sometimes it would be slow to get the data back. So we had an issue with performance of our site. So to facilitate that, we implemented a caching system. So here we have a facade that talks to our weather hardware. One of our requirements was our system to be extensible. So here we can add multiple sensors, and the facade will know how to connect to those sensors and then be able to grab that data. That data then goes to the data proxy, which is then stored in the Redis. To get the data back and forth to the client, we use Socket.io to do more a publish-subscribe system. So the client subscribes to an event. So in this case, the client will be subscribing to the WeatherLink IP, which is our hardware event. And each time the data is updated via the scheduler, it'll be pushed to the client.
So where are we at right now with our project? Well, we've met our core features. So we're displaying weather from the Envoy at RIT. So if you look up on top of the sustainability building, there's a sensor there, and we're pulling information from that. We are now downloading and graphing data. So if you want to see historical trends in rainfall or outside temperatures at RIT, you can go do so. And if you wish to download weather data for use in personal projects or academic projects, you can do that. We have a sweet radar page, which we'll show off later, where we've kind of overlaid radar information on top of a picture of Rochester. We've integrated some third-party forecasts, and we've also integrated some RSS feeds.
All right, let's dive into the demo. I'm pretty horrible at using a Mac, so let's see how this goes. Ooh, Someone that knows Mac should be driving this right now. Okay. Okay, so the main goal of the website was to get RIT-centric weather information to the students. So our home page is just a map of the RIT campus. We've made it set up so you can't move it, so it's kind of an issue when we're zoomed in weird like this. But basically, we didn't want the user to have to do anything when they hit our website to get the core weather information, so it's right there on the critical panel. If there were more sensors on the site, there'd be more blobs on the Google map that you see here, and then you could change between those to get an idea of the weather on a different area of campus. The red building overlay you see was provided to us by RIT ITS department, and essentially it's drawing all those polygons you see that's integrated into a database that then displays building information. So if we go, if I can find the building click on that guy, you can drill down and see building information and things like that. So we'll move on to the forecast page. Chris, you want to explain a little bit what went into this?
Yeah, so NWS provides a series of, maximize that, but anyways, NWS provides us an API that we can get forecasts from. So essentially, we just hit the API for 7 days, and we get the information back and display it.
The archive page. So this is where you can go back and look at our historic data that we pull from the weather sensor and save to our database. So as you can see, we have a wide selection of options that our Envoy is currently saving to the database. So we can select one of those and pick our start and end dates. And then we'll get a fancy graph displaying all that data. So there's no sort of limiting factor in the graph drawing or the data download, which was because the sponsors didn't want to have to add another layer, like a verification layer for the people to gain that information. There's our graph. So that is one concern with us, but we don't really anticipate a lot of users downloading the data sets, especially large data sets, very frequently. So we didn't really think it was a major concern. But as you can see, we have our high chart here that displays all of the information. This lovely line right here is when the sensor is down, as we mentioned, is kind of fidgety. So pretty much every graph you get from those 3 days are going to be that line. But high charts is really nice. It allows us to make clean graphs that if they did support multiple data or multiple sensors, we could show those both at once as well. And you just hit export here. And if you could see the downloads bar, you'd see that it downloaded. All right, let's talk about this radar page. Maybe. All right, so you can kind of see why it took a little bit of time to load. Once again, I apologize for not understanding how the hell to get this all on the same screen. But here are 2 radar images. They're moving in real time. They're displaying different things. What's that? Command minus. Ooh, okay. So, Chris, do you want to explain the different radar?
So at the top, there are different types of radar that you can pull from NWS. So on the left-hand, on the left-hand side, it's the whole Northeast, and on the right-hand side is the weather station from Buffalo. So you can change that, and it'll change the type of radar that's coming that we're pulling from NWS.
All right, our feeds page. This was one of the requirements from the sponsors that they wanted RSS integration so we could have different alerts and basically aggregate weather information, once again centered to RIT students. So we have a couple of RSS widgets that are hooked up to the National Weather Service's critical weather alerts. So right now there is nothing going on there, which is good. Earlier today there was a wind advisory, because as we're all pretty aware it was very windy today. So that's going to be the spot where you see anything severe happening, and then right beneath that is the RSS for just the normal storm prediction center for the Rochester area in Monroe County. So you'll get up-to-date information on possible storms and things like that. The only other RSS feeds we really found were related to forecasting, and since we already had the forecast page, we didn't feel like we needed to add those. And then we have a snapshot of the RIT webcam, the only RIT webcam up so far, and that'll refresh every minute just to show you what's going on in the Fresnel Quad. We have a little about page, talks about the project and the sponsors and everything like that. Let's see, back to the demo. Where's my mouse? Alrighty.
So what went well? For our process, we use evolutionary delivery. That worked well for us because it enabled us, since our requirements changed sometimes during the process, it allowed us to be able to adhere to commit to specific features and get the functionality done. Another thing that went well, we were able to complete the course system early. Essentially, the course system was to be able to save and pull and retrieve data from the weather sensor. And we also managed to meet some stretch goals. The radar, at the beginning of our project, radar wasn't initially going to be in our project, but we were able to put that in as well.
Alrighty, some of the things that didn't go so well. Our biggest issues were definitely process related. We didn't pay enough attention to the agile aspects and really leverage them to our project. So we could have done more paired programming, basically to avoid having individual developers owning an entire area of the project. So if we worked together on things, we would have had two people being aware of a system component, and that way if things went wrong or if new features had to be added simultaneously, it wasn't all put on a single person. And another aspect is daily stand-ups. We could have utilized those more, so that way in our long stretches of implementation there was less gray area basically between the team, and we could have avoided doing some tasks late and things like that. And retrospectives, we had really useful retrospectives, but we didn't translate those properly to actionable things to do afterwards and how to address those things that we talked about. So if we'd done that more in the semester switch, we probably could have gotten even more stretch goals in at the end of the day. As we mentioned, we had a lot of problems with our hardware. It constantly goes down, not constantly, but it goes down sometimes, and obviously we don't want it to ever go down. So that's definitely a pain, and we wish we could have been more familiar with the hardware itself to maybe stop that. And last but not least, we didn't actually get any more of the sensors, so we kind of wanted to put sensors on the quarter mile or around the campus, like academic side and things like that, to fit more of the use case for the website, and we just weren't able to do that. Some concerns for the website, we've done some load testing with JMeter, and as expected, the site does not handle a whole lot of concurrent users hitting it at the same time gracefully. So basically, because of our hosting environment, the only solution to something like that is just to throw more money at the machine, make it a bigger machine, more processing power and things like that, and that's not really feasible for this project. So future goals we can talk about later, but basically there's not a lot we can do about the performance bottleneck, and as we mentioned, there's no sort of limit to the data set interaction. So a mean RIT student could shut our website down if he wrote a script, I suppose. But there's no mean RIT students. That doesn't happen. Last but not least, there's some questions about hosting the website. And as I mentioned, the ITS provided us with that map overlay. So if that changes, we'll have to update that JavaScript basically. So there will be communication later on with future teams and ITS. And there's some concerns on the hosting environment, which we're not 100% sure how to deal with, so we're kind of just hoping for the best with that.
Also, with our database, right now it's hosted on the same machine as our application, and in theory, this is an archival system. This is going to grow. So in the future, there will probably be some need for sharding or some kind of replication, so you just don't lose all your archive data and then you're kind of out of the water. So that's definitely a concern.
So some future goals that we have for our system. So we'd like to incorporate some form of space weather information into the system, give students a sort of another dimension to learn about the weather that we have here in Rochester. We'd like to incorporate a lightning map of some kind so that students could see how close to Rochester lightning strikes have actually hit the ground. We'd like to implement user preference cookies. I know some students love the imperial unit system, others like to use metric. So we'd like to implement some kind of cookies so that we could switch between the two based on the user's preferences. We really would like to have a better mobile styling for our website. You know, it looks all right on the phone, but it's not really optimized for the phone. So we think that considering how often students will check the phone in the morning for the weather, that a mobile website could be a good feature to have. Like we've talked about, we'd love to incorporate additional sensors into the project, just get more sources of information for our IT students. And finally, we'd like to have some more information about some of the hazardous weather warnings that we get going on here at our IT.
So basically what that would mean is if that RSS feed that is tied into the emergency alerts, if something exists in that RSS feed, we want to have some way to show the user that on the home page, so that way they can find out more information immediately if there is an emergency going on. That's it for us. Any questions?
So you talked about the performance issues, and the solution that you're thinking of is that there just at this point needs to be better hardware. But what aspects of, or what technologies
So the number one thing was dealing with the weather sensor. Initially, every time we went to the site, we would request some data from the sensor, but the problem was sometimes we leave it down or it took forever to come back. So when you would go to the site, it might take some number of seconds or even minutes to load if it actually loaded in at all. So we implemented the caching system to where every time the site loads, it'll grab the latest data set in the cache. So at least this way, every time you go to the site, you can actually go to it without it.
And as far as the performance issues with the graph downloads and things like that, I know that there are certain things with Node that allow you to utilize some of the computer's hardware to do certain like heavy lifting things, and we hadn't explored that, so that could potentially be a
just a
solution.
number printing from the database.
Pretty much, yeah. So optimization in general, and then just a parallel user support and things like that for the website.
Yeah.
Have you considered using Twitter instead of RSS for notifications?
We spoke briefly about different options for that at the beginning, but as the project developed, we decided not to go with Twitter. But that could very easily be something we could incorporate into our system.
Basically, we found that RSS widget, and it worked really nicely and quickly, so we threw it together, and we liked it, so we stuck with it.
Well, this is with regard to your database course. Why did you guys decide to go with Mongo instead of a dedicated time series database, kind of like round robin DB or Carbon?
Well, we weren't aware of those options way back at the start. We did some research into mostly SQL and then also non-relational databases. And from kind of talking to other students here and talking from amongst ourselves, we decided that a relational database like SQL wouldn't really be a good solution for the system. And we had a lot of people recommend MongoDB to us. And when we started using it, it worked well. It did everything we wanted to, and it was kind of pleasant to use. So that's why we stuck with Mongo.
Did you run into any performance issues with Mongo with such a large data set that you're working with?
We haven't run into any major ones now, and a lot of the bottlenecks, like Chris said, come from the sensor. So no, Mongo has been, for the most part, pretty good to us.
So can you elaborate again why the radar was so difficult?
Oh, because we get NWS doesn't provide very robust APIs. Like the REST API, it wasn't updated. The last time it updated was like 2005, right? So to get the radar images, they only have them stored on a file server, right? So the only way to get them is you have to download them. So essentially, we had to build a separate service on top of their stuff to grab the images, create the URLs of the images, and then iterate, animate those images.
Were there other APIs you could have looked at using, or just
we could have, but a requirement was NWS. So
the larger weather services aren't very up to date in general, so I'm not really sure if we could have found a better.
Could you install it again?
We could have, but these are updated in real time. So
those look cool, yeah.
It's a problem with positioning the radar on the map too, right? You want to talk about that?
Oh, well, initially I was going to use Google Maps to do the positioning of the radar, but I'm not as familiar with GIS systems, so positioning things on Google Maps was a bit difficult. So I just switched to flat images, and that worked rather well.
Do we have any more questions?
Thank you very much, guys.
Let's try. Oh, not there. How about there? Is that too loud? Anyone? Still too loud? All right, I'll just talk without it then. That was just to get everyone's attention, obviously. We're going to get started a little bit early to begin. Hi, everyone. My name's Greg.
I'm Andrew.
Zach.
Andres.
And with our faculty coach, Rick, we create Hot Tub Time Machine. Our sponsor is Spectracom, and we were hired by Spectracom kind of in a way to work on enterprise class monitoring and upgrading of time servers. Kind of frame what we're going to be doing tonight. Our agenda is we're going to give you an introduction. Who is Spectracom again? Why are we working with them? Through that, you're going to find out we're working on both monitoring and upgrading, as you saw in the title, and we're going to take you through a demo and talk about our potential next steps. So, Spectracom. Who's Spectracom? Spectracom is a local company that is actually just down the road off Jefferson. They manufacture this thing called a time server. For anyone not familiar with a time server, it's a rack-mountable device that provides super specific time to any connected component. This time is super sensitive. It uses a GPS-fed signal, and then it has an oscillator, so if you lose your GPS signal, it can continue to give you that precise time. Spectracom's boxes are spread through mission-critical systems, things like financial institutions, military institutions, places where you don't want to lose a signal. Okay. This is an example of what they currently have on their time server. So you buy their time server hardware, it comes with a software server built in. This is one example of one of their software servers running. You see little things like, is the power connected? What's the status currently? Is there a minor alarm? What NTD level they're at? So it gives you, it's a really nice comprehensive suite of one box, and that kind of segues into where we fit in. So when Spectracom came to us and they wanted us to build out a product for them, they gave us a 3-page piece of paper that kept referencing this idea of enterprise class. We weren't sure exactly what that meant. That could have been, is that a measure of uptime? Is it not a measure of uptime? Is it something we've never heard of? What it turned out to mean is their boxes are purchased by big companies that don't buy just one of these time servers. They buy up to 50 of them. So when you start getting into that level of having 50 time servers, you can't be going through, let me jump back really quick, and logging into one of these 50 times to monitor it. So where we kind of come in is this idea of group aggregation. How can we take this thing that's already deployed across all these places and bring it into one thing to make it easier for administrators, people like that, to work on it? So, and Drew is now going to talk about semester 1, aka monitoring.
All right, so as Greg mentioned, we have this group aggregation problem. We want to monitor 50 boxes at once, not 50 individual boxes 50 times. So we decided that this couldn't be a brand new problem. Companies like Microsoft and Google, they have to have some type of group aggregation problem. So we decided to explore off-the-shelf solutions. And we wrote these one-page white papers on a bunch of technologies that we found. And these consisted of Nagios, Corval, Gigamon, SolarWinds, and a few other ones. And after we presented these to Spectracom and our team itself, the pros and cons of each of them, all of us decided that Nagios was the best fit, mainly because it's open source and it has a plug-in architecture that we can easily adapt. After we decided what we're going to use as a tool, we need to find out what data we're actually going to monitor. And we call these KPIs, the key performance indicators. We built a crawler basically to go through the time server and find out which API endpoints are exposed to us and figure out what data we can actually monitor. And then we built a template for the KPIs, which we'll get into in a second. The arrows, man, the arrows. So this is what Nagios looks like. As you guys can see, we have a host, Aladdin. That would be a representation of our time server. And we have a bunch of these services that Nagios monitors in our time server. As you guys can see, all of the statuses are okay, so we should be set to go. But Nagios also has warning statuses, critical statuses, and if any of these time servers or services go down, Nagios also has an alerting system where we can send you a text message, email, phone call, whatever. So on top of that, it was nice to know that actually Spectracom had customers that were looking for Nagios plugin services. So when we decided Nagios was the tool to go to, and they said that only kind of pushed us forward with it. These are some of the KPIs that Spectracom prioritized for us, and these would be the services that you would see in the boxes that hook up to Aladdin. We have number of satellites working, the oscillator current state, power status, and the PTP options. And so that was semester 1. And Zach.
So we got to a point with that where we were able to just pump out new KPIs at a good rate. We were able to just add new plugins to Nagios that would hit different endpoints. So SpectraCon came back to us and asked us to work on another sort of group aggregation problem similar to that last one. This time we needed to deploy updates to all of these to all of these time servers. We also made some other changes at the halfway point. We switched from a sort of loosely based Scrum process to a more pure Scrum process. This time around we used 2-week sprints with a really good Scrum 0 over the intersession to get started and get ready for this new project of the upgrading. Some of the examples of the requirements for this new semester was the ability to view all time servers on a given network, view the current status of each box and the version of the software installed on that box. We need to be able to push the update to the boxes and then apply that update on that box. There were a couple different update strategies. One was to apply an update to one box at a time, and once that was done, you could apply it to another box, and during that chain of upgrades, you could cancel the update, or you can just push it out to all of the time servers all at once. And additionally, while these boxes are upgraded, we had to have the ability to log the status of the upgrade and see if the upgrade passed or failed, or where in the upgrade process that individual box was. Here's an example of the connection structure. So we created a web server that had a database to sort all the different time servers on the network, all of the available updates for the different time servers on the network, and the credentials to access each of the time servers. We were able to push to updates to each of the time servers using SSH, and then through that same SSH connection, we were able to apply the update and read the log of the update progress. Jumping back to semester 1, we also created a web server that called RESTful APIs on each of these time servers and collected these into a metrics database, which is displayed to Nagios. So Andres is going to give you a quick demo of the upgrading system.
Alright, so I'm going to quickly go into, log out real quick. Anyways, this is our staging server here. It's hosted on spectrum.seanstrout.com. And basically, the home page is very simple. Any kind of information is kind of hidden away under the login screen. You need to be authenticated to be able to see any information. So I'm going to go and quickly go and log into the system. First, I want to point out that right now our staging server is behind SSL, so that all the data is encrypted in traffic. We don't want anybody snooping on username, passwords, or any kind of sensitive information. Additionally, we're using off-the-shelf authentication framework called Device, which means that takes all of that security risks and problems out of our hands and into an industry-tested framework. Here we're logged in. This is the main page. As you can see, we have 3 time servers here. You can see the basic information, the name, the host name or IP associated with them, and some quick actions that you can take with them. I'm going to go and walk through the application first. And here is the admin interface. This is the list of all users that have access to the system. This, in the future, could easily be managed through an LDAP server, but right now we're just doing our own authentication user mechanisms. There's 2 types of users, admin and non-admin, so you can toggle that here. You can only see certain pages if you're an admin, and you can only take certain actions if you're an admin. Primarily, if you're not an administrator, you can only really see the time servers and their current version. You can't really see anything else. Additionally, you can also lock users out of the system. So if you have an employee who left the company, you want to lock them out, you can do that. But you can't lock yourself out, as you can see here. It gives you a nice little error saying, hey, you're not allowed to do that. And there's also an important part, as my friend here, Zach, mentioned. We use SSH to log into these servers. How do we store the information to be able to log into these servers, we have these things called credential sets. Basically, it's a set of a username and password or key path or both. Basically, since all these credentials are usually associated with more than one server, we thought to separate that outside. And we also encrypt the password on the database. And it's two-way encryption, so you can actually see it on this side of things. But it's encrypted using, again, already pre-built security mechanism to be able to do dual encryption with its own salt. And for those who don't really trust our authentication or who already use key-based authentication, they can upload the private key here to be able to go through and update their systems. Here is the list of update packages. Update packages, or update bundles as they're called, are the zip file that will push the updates to the server. Basically, you push this file, and this file gets run through a program that will actually apply the updates. Ideally, we'd like to be able to populate this list automatically from Spectrum's website. Right now, the way the process works is you receive an email from Spectrum saying there's a new version available and a link to download the file. There's no central repository that we can go and download. But ideally, we'd like for all the updates to be listed automatically from Spectrum's server, and you can quickly update and have all the information populated automatically. But it's very easy to actually create a new one. All you need to provide is the version, changelog, and then the actual update file. And I'm going to go and quickly give you guys a quick demo of how the actual upgrade process works. So I'm going to go click here. I'm going to update these two servers. Right now, this is in demo mode. Since we only have one time server available to us, we can't actually update more than one time server. So this is what it would look like. But we've actually tested it with actually upgrading the servers. But for demonstration purposes, since the process takes 20 minutes too, we're kind of going to go through a quick version of it. This page to be able to set up a upgrade. Here you can toggle whether you want to do a sequential upgrade or a parallel upgrade. And then you can select the version here. This is populated based on the update packages or bundles. And then these are options that are available to the users on a per individual machine basis, but these can be applied in bulk, which is a big bonus. And this is a little confirmation, and I'm going to trigger the upgrade. And as you can see, this is the page where you can view and monitor the status. I'm going to go quickly and show, this is the first one. All right, so this is the log as it's being populated from the server. This is information coming from a SSH server, from an SSH connection, and we're basically just spitting the output log into here so that they can monitor it. And if you had multiple running at the same time, you would see all the logs running at the same time being updated in real time. And yeah, we're really, really proud of this, especially the way we architected it. There's a lot of very complex upgrade schemas that many clients might have. So we built it in a way that you can build a sort of dependency graph between time servers or groups of time servers, so that once a certain group or a specific set of machines are all upgraded, then you can trigger and kind of follow down the path of what servers get upgraded. So you can make very complex upgrade mechanisms into it, and that is something that we'd love to be able to work with in the future to try improve the system and make it better for Spectrum's customers. And yeah, you can also cancel upgrades. You can't cancel them as soon as they start. That's a limitation of the current software. But you can cancel them before they start, like I'm going to do here. And that one won't actually ever run. And yeah, now I'll leave you with Greg.
Well, thanks, Andres. Again, kind of 2 semesters of a project. Nice. You saw what we did with semester 1 with Nagios. Now you've seen what we've done with a demo of semester 2. Now we want to talk about what would next steps be. The first one that's kind of logical is combining them into one thing. Though they seem like they're kind of separate entities, monitoring and upgrading, we feel that one solution could be built eventually utilizing both. We also want to expand authentication like Andres mentioned. Currently we use Devise, which is working really well. A lot of companies already use their own things like LDAP, so it'd be nice to have that sort of integration coming. Graphite is something that we didn't really get a chance to mention.
we were initially focusing on monitoring. During that time when we were focusing on monitoring, we got to a point that we were calling to turn the crank, so we figured out the KPIs, we'd done our proof of concept, we knew this could work, so what the next steps would have been would be more of like an analysis-driven thing. So now we're collecting all this data, we want to present it in a really nice manner, so Graphite would have been this visual analysis of it, so it would provide graphs that you could go in and you could inspect and kind of dig into your data a little more. We mentioned configuration testing in real environments. We only had one SpectraCom box, they're expensive, so we were happy to have one. But because we had one and we're doing something at a group level, the testing wasn't ideal. Automatic downloads of new updates and packages was another thing Andres had mentioned. Current limitation of the way it works. SpectraCom, they release updates, and the way they do it currently is they send you an email if you're a client. In the email they say, we've released this new version, this upgrade version, this is what it changes, and here's where you can get it, or this is where you download it. There's no mechanism for us to really do it ourselves and bring it in. So that was something that we would like to see.
I think what we talked about for that point was, I think we were aiming for some type of like RSS feed or something to do the automatic downloads, but just due to limitations, we didn't get it. So,
right. So now that you know what we want to do next, we're going to talk about how the project actually went. So what went well? We want to start with the good and then go to the bad. Team formation is something we want to call out. We all know that you go through this storming, forming, norming phases. Our storming phase wasn't very long. It went pretty fast. We all sort of fell into our roles, and I wanted to call that out because I think that was a big reason we were so successful is how easy we were able to hit the ground running and kind of get comfortable with each other. Sponsor satisfaction is something we're calling out. Obviously, the whole point of this project is to make the customer happy, but we felt in this case we did a really nice job, especially when it came to the time of here's the semester one project that we thought we were going to focus on. Now it's time to kind of switch gears. That's why we kind of came in over intercession and did some work to kind of ease that transition. But again, it was all to make our customer happy, and we think we did a good job of that. You'll see good rhythm and accountability mentioned here. What I mean by that is we're all seniors. We all kind of have other things going on. People are flying out to jobs. It's very hard to all stay on the same page. So we didn't really use Agile. In the beginning, we called it Gregile. Then the second semester, we switched to a pure Agile. But during those times, we always used time boxing. And the time boxing is what I mean by good rhythm and accountability. The time boxing provided us a chance to always synchronize and a point that we could always hit. The last thing here is Salsaritas. A big implementation we did in our second semester is we started meeting every Tuesday at Salsaritas, do our statuses or our stand-ups at the Salsarita table around chips, and that really improved team morale. Hold on.
I mean, just with the rhythm and accountability, we met with our sponsor every week, every Friday. We had a meeting with them. We went over everything that we had done that week. We worked on them to write acceptance test for all of the stories, help them write the stories, and that was how we got all that great feedback. It's, every Friday, we would, sit down with them and go through it all. We would always groom the whole backlog.
Yeah, thank you for pointing that out.
And
yeah.
Salsaritas.
And again, Salsaritas.
Man, Zach got a job at Salsaritas. I'm sorry, dude, I had to do it.
Okay.
So, what needs a little bit of improvement? Testing is something we called out, and some things we wanted to improve moving forward, and it's something that we know we need to improve. Initially with Gregile, we weren't doing a pure Agile thing, so we didn't really do any test-driven development. This time, when we actually switched to Agile, we started using test-driven development, but over time it became a little bit harder as the task became a little more complex. Although we did implement testing, it's not up to a standard that we really like. That's something. Using metrics to improve the process. So one of the big reasons we switched from Gregile to actual Agile is because you could get these metrics and improve the process even further. So now we had these metrics, and we didn't use too much besides figuring out what our average velocity was, or just little things where bottlenecks could be improved. So that's something that the whole reason we switched to it, we should have used a lot, or utilized a little more. You'll see enacting scrums and goals of communication. That's kind of, again, what we were touching about earlier. We got into a good rhythm, but we kind of had to teach Scrum, and not all of us were all familiar with Scrum. So it's something now we were much more comfortable, and we're happy for the experience, but at the time, we probably didn't teach it in the best manner. So one of the things we wanted to call out. With that, that is the end of our presentation, so we'll open it up to questions.
Yes. So 2 questions. Sure. First is, if I want to do some mean things, being a mean person, one thing I would definitely do is to do something so one of your updates had a virus or something in there, so that I messed up all the time sensors and yeah.
Yes.
What protections do you take?
So we don't do anything about that. They actually have checksums embedded in the upgrade bundles. We are just calling a tool that they've already written that takes into account all of those types of things.
Second question, just so I don't miss it, what time is the Luau?
Well, I mean, it's
5 minutes.
about 5 minutes.
Anyone else?
So if there is a botched upgrade, is there a way to roll back?
Oh yeah, that's the force upgrade option that allows you to go back in versions. Also the clean upgrade, what that does is it clears all the configuration off the machine. So those two mechanisms are in place.
The actual upgrade, like you have like a progress bar going on there. Is that a real progress bar, or is that one of those ones that just keeps going no matter what?
So no, for this actually is a real progress bar. For demo, since the whole process takes about 20 minutes, we're actually not going to actually demo that. But in the real progress, what it does is it waits. We know what how many lines of output we're going to expect. And if we encounter an error at any point, we roll back to 0 and then display the error on the log. Otherwise, we keep track of the progress. At one point, the machine goes down, so we have no longer a wait to progress. So there we wait at 80% until we see the machine come back, and then we roll to 100. So it's in real progress bar.
So you really do get that wait right toward the end.
Yes.
Just like a real progress bar.
Just like a real progress
each part,
bar. Yeah.
each part of the update is part of the actual progress bar. This is just the demo mode. So.
I have one more question. Are you using the you had shown the status, the third-party tool you're using, it had its own interface?
Yeah.
Are you integrating that into your?
Not right now. That's part of what we want to do in the future is bring the two together. Right now, there were two completely separate projects that could be brought together in the future.
Yeah, and Graphite would have been a nice tool to not only do analytics, but provide us with some UI benefit to graphing the data and showing it alongside Nagios. So.
There's a question in the back.
Is the question mark on this slide a hyperlink?
Yes, it is.
What does it do?
So I happen to own SeanStrout.com. And I don't know if you know, but he's a really big Boston fan. Every time you refresh it, it posts different Boston hate.
We love Sean Stroud. Don't worry about that. So.
Keep refreshing.
I guess this fits since we're all in New York and not.
Any other questions? Well, thank you.